Okay, the diagram shows two straight lines intersecting O and two circles, each with centre O. The outer circle has radius R, so the outer circle has radius R, so that would be this one here, call that big R. And then the inner radius has radius of smaller. Okay, so what we're going to do is the area of an arc equals a half r squared theta. Okay, so what we're going to do is going to get the area of, we're going to call this angle x is on both of them. So we're going to say an angle x is in radians. So therefore area A equals, it's going to equal this full area here, which I'm going to get now. It's going to be a half r squared, capital R squared x, and then this green area here, which is going to be minus a half small r squared times x. Okay, area B is a half small r squared x, and now we've got to calculate the ratio of big R to small r. So what we're going to get here is area A followed by area B. So what we're going to get, area B is 2 to 1. Okay, so what we know is that a half r squared x minus a half small r squared x is equal to 2 times area B, which is a half r squared x. And multiply that out. We're then going to find out is that a half big R squared x is equal to, it's going to be R squared x, and we're going to move that over, it's going to be plus a half small R squared x. So a half R squared, we can cross off all the x's, is equal to 3 over 2 small r squared. R squared equals 3 small r squared, or therefore equals the square root of 3r. So the ratio of 1 is to root 3. So the ratio of big R to small r is root 3 is to 1. Okay, let's move on. Number 24. Given that AB equals 20, that means this will equal 10, this one here equals 10. Circle K has a radius of R, as shown in the diagram. PQ is worth 5, so that's PQ from here to here. Okay, and then calculate the following to 1 decimal place, the length of the radius of K. So what we're going to do here is make a formula, like so. Now, key thing about this formula to remember is that we're going to call that side x and this side r. Now remember, your radius equals x plus 5, because that will be this distance here. Okay, now we're going to do Pythagoras' theorem for the triangle r squared equals x squared plus 10 squared. Therefore r squared equals x squared plus 100. Now we can make r squared out of the top equation as well, so r squared equals x plus 5 to be squared. The same thing as x squared plus 10x plus 25. put this equation here equals this one here. So x squared plus 100 equals x squared plus 10x plus 25. X squares cancel, bring over to 25. Then we're going to get 75 equals 10x. X equals 7.5. I'm going to say that is question 24 being 7.5 centimeters. And that's what x is equal to, not the radius. So remember, the radius equals x plus 5. So radius therefore equals 7.5 plus 5. Radius therefore equals 12.5 centimeters. Now, find the area of K. Well, the area of K is the area of a circle. So area equals pi r squared, which is going to be pi times 12.5 squared. Pi times 12.5 squared. So shift pi times 12.5. We get there is 625 over 4 pi, or otherwise known as 490.9. Find the area of the triangle AOB. AOB being this triangle here. Now, I could do a half base by height on each one, because I know that the x value is 7.5 and this is a right angle triangle. So area of one triangle, so area of this triangle here, if you will, equals a half base by height, which is going to be a half 10 times 7.5. Now remember, there's going to be two of these triangles. That's going to give me 37.5. But there's two of them because there's another triangle that's the same size over the other side. So we're going to multiply this answer by 2. Yeah, 27.5. We're going to multiply this answer by 2. And we're going to get 75 centimeters squared. So 75 centimeters squared. The angle AOB. So the angle AOB, if you will. Okay. So the angle AOB, you can turn that into, I suppose a good way of doing the angle AOB would be that's 12.5, that's 12.5, this whole thing here is 20. We could do the cosine rule, okay, or we could use the angle, we could use the cosine rule to find out what x is, or we could say a half AB sine C equals 75. Therefore a half 12.5 multiplied by 12.5 sine x equals 75. So just a half 12.5 by 12.5. So 12.5 squared. Half the answer. This answer gets divided into 75, so 75 divided by your answer. So, sine x equals 24 over 25. So we're going to inverse that answer. Shift, sine inverse answer. And we should get 73.74. Now you can clearly see that this angle here is the obtuse case, not the acute case. So it's going to be 180 minus 73 minus 73.74 degrees, and that is going to give me 106.26 degrees. It can come up that way in the cosine rule as well. It'll definitely come up as 106. Okay. Now, the length of the minor arc AB. Well, your arc formula is L equals r theta, where theta is in radians. Or L can be equal to theta over 360 multiplied by 2 pi r, where this time it's in degrees. Okay, so we're going to get here is that's 106.26. So we say is 106.26 divided by 360 multiplied by 2 multiplied by pi multiplied by 12.5 will give us the arc AB. The arc AB being this length here, and the angle it's opposite is the 106.25 or 106.26. So let's see how this comes out in the calculator. 106.26 divided by 360 multiplied by 2 multiplied by pi multiplied by 12.5, and what we get here is 23.18 or 23.2. Now the minor arc AB, they want also the area of the minor sector. So the area of the minor sector, same deal. Area equals theta over 360 multiplied by pi r squared. It's going to be 106.26 divided by 360 multiplied by pi times 12.5 squared. So what we get here, divided by 360 multiplied by pi multiplied by 12.5 squared equals 144.9. So 144.9 centimeters squared.